that. Okay. Okay. So last day we talked about the DNF, the disjunctive normal form of an algebraic function or a Boolean algebra function. And so today we're going to jump in and assume that we've got that under control, and I'm just going to give you the DNF. And I don't know, for some reason I just feel like maybe, just maybe, we should just do a scroll through of what the DNF is. First question, 3 or 4 variables for those who are here?
Always 4.
Always 4. Oh my gosh. Oh, making me work for it.
No, not do 3. Don't do 4.
I know. Okay. So you can go through and you can use a truth table to find the disjunctive normal form. But what the disjunctive normal form is it's a sum of fundamental conjunctions of each of the literals. Definitions. Dang it. And so what we do is we have each of the literals. Remember, the literals is each individual term. So in this case, we have 3 literals, X, Y, Z. And so that's when I asked if you want 3 or if you want 4, W, X, Y, Z, right? Gets a little bit more complicated. I've already promised on the final exam, it'll only be 3. Whoop, whoop. Which you'll appreciate, especially later on today. And so if we have this function, xy plus the complement of x times z, then what we do is we make a little space for each of the missing literals. And what we do is we multiply by 1, a convenient value of 1. And so, of course, we spent a lot of time talking about the Boolean algebra laws, which are on your formula sheets. And if you don't have a copy of your formula sheet, you can grab it here. But we use the complement laws that if you have, let's say, x plus the complement of x, then that's going to be 1. So if you want to multiply by 1, you can multiply by x plus the complement of x. Okay? And so that's going to be a go-to move. And so what we do, where was I? Here, is we see that, okay, in the original function, I have an x and I have a y. I'm missing a z, so then I make a little space for z, mostly in my mind. Here, I'm showing you what I'm doing, but you can just go straight here if you want to. Here, I have x. I've been saying x complement of x times z, so I make a little space for the y's, making sure that you're always listing them in alphabetical order. Otherwise, it's going to be hard to keep track of. And so then what we do is we multiply by 1 to get this kind of convenient value of 1, which doesn't alter the equation, right? Multiplying by 1. But then when we distribute, right, xy times z makes xyz, xy times the complement of z, xyz complement, and so on and so forth. Okay? And you're allowed to remove any duplicates because they cancel. Well, they don't cancel out, but you've already said it, and so you don't need to say it twice. Okay. And so what we can do, is if we have something like xy, the complement of z, what I can do is I can say, okay, x is on, y is on, z is off, right? 1, 1, 0. Looks familiar, right? And so now what I can do is I can assign it to some label 6. Then our DNF, we can write So we're going to convert each of these into a binary label, and then we're going to have just a regular label. I don't know what we're calling it. And so the DNF, the disjunctive normal form, which you will have to do on the final exam. So gotta practice. The disjunctive normal form in this case is going to be, and what you do is you take the sum of the min terms. Now that's just notation, and you can kind of just put that down, right? And then you list them in increasing order because otherwise it's hard to read, right? And so then you have 1, 3, 6, 7, right? So instead of saying, okay, this is the disjunctive normal form of f of x, y, z, instead you can say, well, it's the sum of the min terms of 1, 3, 6, and 7. And that's where we're going to start today. We're going to have the DNF, and then we're going to simplify it using Karnaugh maps. And we did lots of examples last day, but just as a reminder, I'm going to do final exam review, just kind of talking about the types of questions to expect, and a couple of examples, obviously not the entire thing because that's crazy, but final exam review on Friday. And then nothing on the Monday. You deserve it. Cancel. We're all done. So that's it. Is that even canceled?
You just moved everything up way.
Yeah, we've been marching along and leaving everyone else in the dust. So no class on Monday, which means where's the sad one? No class on Monday. I know, so sad. But it means we're done on Friday. Any questions about that before we start? Okay. I don't think I can control the lights in here very well, but can you see the screen okay?
Can you just turn it off?
Oh, really set the mood, huh?
I think some people are on pen and paper, so maybe not completely off.
How off
I
is
think
that?
that's pretty good. Can you?
Yeah, that's fine.
Is it okay?
Yeah.
Fall asleep in here?
I
I mean, it makes the screen really crisp. Okay. Should I read it nice and slow and low? Karnaugh maps, K-maps. We use maps to simplify Boolean functions. Specifically the DNF, which can get quite large, as we saw sort of last day, right? And so what we can do, and this is where we're jumping off from, once we've found the DNF, which is where we're gonna start from today, what we can do is we can create a map of the variables. Okay? And so if we only have two variables, let's say X and Y, then it would look a little something like this. X, Y. And so on this lower or the vertical axis, I'm going to have my X values. The possible values for X are 0 and 1. And then on the horizontal axis, I'm going to have the possible values for Y, which are 0 and 1. Because it's our first one, I'll just make a note here that this is the 0 for X is saying that X is off, right? And a 1 for X is saying that X is on. Whereas here we have Y is off and then Y is on. Yeah. Then as long as we read the X's first and then the Y's, mostly because we want to work in alphabetical order, we want to have some sort of order. And so I want you to read it from the vertical side first over to the horizontal. And so what we're going to have in here is we're going to have 0, 0, right? 0 for X, 0 for Y, 0, 1, 1, 0, and 1, 1. We can convert these to binary labels, which is what we have in our DNF, right? And so we have labels. Now I'm hesitating on the binary. Are these binary labels? Or if I convert this, for example, to 1, is that the binary label? Grain of salt. Binary label? I didn't hesitate when I wrote it, but now I am. So anyways, what's this thing look like? Same deal. X, Y, 0, 1, 0, 1, 0, 0 in binary is 0. 0, 1 is 1. 1, 0 is 2, and 1, 1 is 3. So if we had a cute little DNF with only 2 literals, X and Y, then we could map those on here. I'm not going to talk about how just yet, because we said, well, we're probably going to have 3, right? So let's. How I want you to set it up is for 3 variables, we're going to use X, Y, Z. And what I want you to do is I want you to have X down here and Y, Z up here. That's not a hard and fast rule. As long as you're following the labels, then you can technically write it however you like. But for consistency, for me having to read it when I'm marking and being nice to me, then I want you to use this setup. There are online calculators, so Karnaugh map calculators, and then you might need to rearrange things a little bit. But for me, this is how I want it for 3 variables. So we only have 2 options for X, but then we're going to look at combinations of Y, Z. Now the note and what I learned the hard way earlier today, or remembered the hard way earlier today, was that we can only change 1 literal at a time. Okay, and so here, as we move across, because we're going to have maybe Y off, Z off, you're only allowed to flip 1 switch at a time. So in each move over. Okay, and so here, note that with each move, and by move, you'll see what I mean, but move, only 1 literal may change at a time. Good a place as any. Start at 0, 0. Right. 0, 0 is the same thing as saying, what did I use before? Y is off, Z is off. Then we're going to move through, only changing 1 thing at a time. Now, the next move that I'm going to make is 0, 1. we think about, so if this is 0, 1 in binary, right? If we're gonna rewrite these as labels, then if I want to have 2 here, that's gonna be 1, 0, but that means that I would have to turn Y on and Z off, and I'm not allowed to do that. So that's where I really got into some trouble, because I thought, oh, wouldn't it be so fun if we could just have them all in order? No, we can't. So from here, we're gonna go 1, 1, which is weird, but you'll see, and then 1, 0. So here, these guys, one literal may change at a time. Huh? So
It doesn't look how the order works. If you make
You
one
just-
0 and make the one in front of it like negative and the one after it positive.
negative,
No, just imagine it that way.
maybe. I mean, I am not very good with this stuff, and you guys are way better at it. But I do know about Karnaugh maps, sort of. Even, yeah, so you might have heard Steve, I was like, all right, today I'm gonna teach Karnaugh maps. He's like, what is that even? Like, I'm lost. No, it's fine. It's fine. We want to have a look at what values are represented in each of the cells, then we can say 0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 0. We convert these to labels. Now, pretty soon, I'm going to switch to just writing the labels immediately, because once we have a pattern going on, then that's going to be pretty quick to do. So X, Y, Z, still 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So now I'm starting at 0, 1, and then you have to jump over to the last one is 2, and then this one is 3, right? So here, notice that these two, can't highlight this enough, right? But once you have that movement in your brain, right? 0, 1, 2, 3, then it's fine. One, 0, 0. Wait, that's a highlighter. 4, 1, 0, 1, 5. I mean, I guess you guys are so savvy with the binary, probably don't need the pattern. I need the dance. 1, 2, 5, 6, 6, 7. Right. So again, making sure that you notice that those are changed up. If we wanted to, we could write this table, but in terms of X, Y, Z, the literals, right? And so then what this would look like, and this is just for an understanding of what we're saying in this table. X, Y, Z. 0 is the same thing as X being off. 1 is X on. And then 0, 0 is Y is off, Z is off. 0, 1 is y is off, z is on. 1, 1, y is on, z is on. 1, 0, y is on, z is off. Which we can mash up. Right. X off, y off, z off, x off, y off, z, x off, y, z, x off, y, z off, x, y off, z off, x, y off, z, x, y, z, x, y, z off. Right? You could skip the sum of the min terms notation if you wanted to, right? Because what did we do? We had some combination of these fundamental conjunctions, right? And we had the sum of them. And then what we did was we converted them to binary, which is what we got these from, right? And then we converted them to the labels. So we're just going back and forth between these two. Okay. So what we're going to do is, after finding the DNF, the disjunctive normal form, as a sum of min terms, we map the labels on a Karnaugh map. Okay. So if I have X, Y, Z, so 3 variables, what I'm going to do is I'm going to map each of these min terms as a 1, and everything else is going to be 0. And usually I just kind of ignore the zeros. I don't even write them out necessarily, because they're nothing. All right. Let's see here. So I've got X, Y, Z, right? 3 terms. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Same layout. So what I'm going to do is I'm going to put the label on here now. And this is where you being so savvy with your binaries is really handy. 0, 1, but I have to do the dance. 2 out in the corner, back to 3. 4, 5, 6 out in the corner, back to 7. We don't have to do this. So this is optional. So I am gonna just make a copy and paste it here. So what we're gonna do is, over in this original, we're gonna circle all our min terms, 0, 2, 4, 7. So I've got 0, 2, 4, 7. And I'm gonna circle those here as well, 0, 2, 4, 7. But instead, what I'm going to do is I'm going to replace the 0, 2, 4, 7 slots with 1s. And like I said, this is optional, because I find that it's, I don't know, just as easy to just work with these circles instead of 1s. Doesn't really matter. Which means that everything that's left over is just going to be replaced with a 0. If you want. Either way, so here, this is an optional step. If it helps you see it better, see what, you ask? I know, right? If it helps you see groups of 2, 4, 8, potentially 16, and so on and so forth, then That's what you need to do. So what we're going to do is we make groups of powers of 2. So maybe things like, show, 2 to the 0. It's down here, but I'll just write it here. 2 to the 0 is 1, 2 to the, oh, sorry, skip 1. 2 to the 1 is 2, 2 to the 2 is 4, etc. So we make groups of 2 or some order of 2. Trying to make groups as large as possible. And one thing to note, and I'll do it in red, is that the table cycles. Okay. So what I mean by that is that, okay, this 1, 0, we picked starting at 0, 0 arbitrarily. We could have started at any point if we wanted to. And so we could have started at 1, 0, which means that this becomes this this roll, right? And you can, that might be a fun project. Take like a toilet paper roll, make a Karnaugh map on it, groups of 4 or whatever. And so what does this look like? Right, so this, it's gonna cycle, right? You could have just as well written 0, 0 following, again, only flipping one switch at a time, and then you could have cycled through. So sometimes it's not obvious. For example, you have this 1, which I can link up with this 1 to make a group of 2 next to each other. So what we have, I'm gonna work in, I guess I should ask, what do you prefer? Do you want to just work from here or do the 1s and the 0s? I kind of flip-flop between the two, which isn't very helpful, I guess. But this is our first one. So let's see here. Well, I kind of drew all over this one, saying that the table cycles. So maybe, just maybe, I shouldn't do that. And yet here we are. Okay, so we're trying, so I gotta catch them all. All the ones that are in our DNF have to be caught. And so what are some options here? Well, I see a definite group of 2. Usually what I do is I try to see if I can extend it. So I can't make a group of 3 because it has to be something 2 to the power of something, right? And so, but I can make this group of 2. So we'll start there. How can we summarize that group? That group is varying across X, but for all of these values, 0, 0. So what we could do, we could summarize this column as Y is off, Z is off. And it doesn't matter what X is doing, regardless, Y is off, Z is off. And so what we're going to do is we're going to say, okay, here, 1, we can summarize as Y is off, Z is off. And maybe I'll put this closer to the red, but where? Smaller. deciding what a group can be summarized as is going to take some practice, right? And so I have to really, really slow down and think about it. And there's no point in going fast. What's another way that I could group these? Now, my groups are allowed to overlap, okay? But you don't want to have redundant groups. If you've captured something and everything's all kind of captured in your groups, then you don't need to keep making groups. Okay, then you're done. So I'm going to go 0, 2, because these guys go here like that. Call that my second group. My second group, how can I summarize my second group? So X is off for both of those. Y is off here and on here, so that's not steady, right? But then here, Y is off, Z is off, Z is off. So I can summarize this as X is off, Z is off. Yeah.
So do we choose 0 and 4 just like there was in line, like the numbers that were circles? And then since like
Yeah.
it's below, okay.
Yeah. Yeah, so we're trying to find groups. And usually, I mean, technically we should have been looking at the ones, but I just skip straight to here sometimes.
And then,
Or sometimes I don't write the labels and I just write ones where I need them.
yeah. And then like random question, we said like groups of powers of 2, like I was thinking like, do they have to be even, odd, or does not matter?
Yeah, so they can be, so you have as many as 2 to the power of literals options.
Okay.
And so if you have 4 literals, the biggest square or the biggest grouping that you can make is 16.
Okay.
Right? So then, which is like the biggest thing that we would consider. And so your groups are going to be groups of 1, because if you have something like this, that there's no way you could lump this with anything. 2, 4, 8, 16.
Okay.
And those are your grouping options. So you're not allowed to go on the diagonal, for example, though tempting. So then we're just left with this little guy all alone. And I guess I should pick a more different color. I've really exhausted them. Pink. Fine, I'll use pink again. Just because it's the most distinct one. So there was nothing I could do about that lonely 7. So what can I do? I can communicate that is when X is on, Y is on, Z is on. Therefore, sounds like we're done. We are. How can we rewrite this DNF? We can simplify this disjunctive normal form. F of X, Y, Z is Y off Z off plus X off Z off plus X, Y, Z. Neat. Yeah.
For number 2, why didn't we put Y? Because I thought it would be like Y and then not Z.
Oh, this one?
Yeah.
Oh, because Y is all wishy-washy. So in this term, Y is off, and in this term, Y is on. So what that means is it actually doesn't care what y is doing, as long as x is off and z is off.
Oh,
Because it doesn't care regardless of what y is doing. As long as x is off, z is off, then you've captured that entire group.
okay.
The bigger your group is, right, the smaller this term is going to be, right? So here you have a tiny group. And so then if you're able to build a bigger group, which is always going to be our goal, then you can summarize it by something simpler.
Oh, so that means like, even if like they're all in groups of on and off, not makes sense.
Yes. Let's see. Let's do another example, shall we? I've got some notes here, but we've said them all before. But so we need to make our groupings in powers of 2. So 2 to the 0, 2 to the 1, 2 to the 2. And you always start with the largest possible grouping, right? Try to capture as much as you can and then get smaller. Right? The map cycles, so groupings can be made from one end to the other, and later also top to bottom. And groupings are allowed to overlap if necessary, right? If necessary, but do not include redundant groups. Got an example of that, right? But a redundant group would be if all those points or all those values have already been grouped, right? So all values are already in groups. Then you could make another group, right? And so you want to kind of be strategic about how you set up your initial groups so that you don't have to have more groups than absolutely necessary. Because I wasn't sure how the printer was going to behave today, I smushed all the examples that we're going to do at the bottom of the page. So it looked like it was going to be such an easy day. And bam. It was looking so good, right? So I'm going to put these on a fresh page. I guess I already have one here. Gonna need some lines. Boy, whoops. Okay. So we're gonna use a Karnaugh map to simplify this thing. And we're gonna keep doing it for all these examples, and then you're done. So let's see. Start off, warm up a little bit. So let's start with our table. I've got X, Y, Z. I'm going to start 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Gonna hop in with my labels right away. And so 0, 1, over, 2, back in, 3. Right. Just remember that dance. 4, 5, over, 6, 7. my notes, I have pretty consistently been really good about converting to ones. Or do we want to just group from, oh, hello? Is that me? Who's you? Phew. Just, I was so distracted. Yeah, so what's the option here? Copy, paste. We could rewrite this. Well, first we need to figure out which ones we have. 0, 2, 4, 6. And I know I cheated. I'll make a note here that we could group from here. What's another thing we could have done? We could have remembered what all these ones are and then just put a 1 where you want them. That's nice too. So what I want here is this is a 1, this is a 1, this is a 1. And these guys are all zeros. Sometimes, like I was saying earlier, I don't even write the zeros because they don't do anything. All right. So we see the grouping, one big group. That is nice. All right. How? Because if we go and roll around our toilet paper roll, we can lump these all into one group of 4, right? Because in theory, and I'm going to change my pen style here. In theory, I could have written 0, 0, 1, 1 here, right? And made that a group. So just because I didn't, right, cycles through. And so that's how I see that that's a group of 4. How do I summarize this group? This is what I struggle with. Okay, let's see here. For each of these, so let's look at all of these together. Both values of x, so x is off, x is on. So that's not steady across these groups. Here, y is off, y is on. So that's not steady across these groups. And in this case, z is off, z is off. So the overall summary of this group, because as long as z is off, we don't care what y is doing. It's allowed to be on or off, right? Those are all options in this group. We don't care what x is doing. It's allowed to be on or off. And so as long as z is off, summarizes this group. Let me write down what we were saying. So notice in this group, x is on or off, which means it's not steady. Y is on or off, not steady. But Z is off in all values of this group, right? Across the entire grouping. Therefore, Z off summarizes this group. I am simplifying a little bit because it's our first-ish one, right? Second maybe. But one of the things that we need to look at is whether all of the options are taken into account, right? And so here, 0 off, or sorry, X is off, X is on. We'll see an example. Simplifying a little bit. Simplifying in my simplification. So then what can we do? We can rewrite f of x, y, z as just z is off. That's cool. Right, we started with a list of 4 fundamental conjunctions, or the sum of 4 fundamental conjunctions, which can get quite big with 3 literals, right? And then we summarized it, how boring, I guess, as z's just off. How about 0, 1, 2, 3? Let's see here. Still x, y, z. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Are we ready to try it? Looking at 0, 1, 2, 3, what I'm going to do is just write a 1 in those spots. So I'm not going to write out the spots anymore. I'm just going to throw in a 1. So here, write a 1 in the appropriate spot right away. Right, save you a little bit of time. I know that, okay, 0 is here, 1 is here, 2 is here, and 3 is here. All the other ones are zeros, which you could just leave blank if you want, or put zeros. Once we get a bigger table, then I won't do the zeros, right? Because we're not grouping zeros if they don't matter. But it is easier to see the spacing, I guess. All right, we've got a beautiful group of 4 just staring us in the face. How do we summarize this group? Well, it's all the values where x is off. So, right, this is where x is off. Doesn't care what y is doing, right? Y is off, y is off, y is on, y is on. Z is off, Z is on, Z is on, Z is off, doesn't matter. All of these are summarized by x being off. So f of x, y, z is x is off. Bigger. Let's see if we can pull this off. I know we can. X, Y, Z. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Again, knowing where these positions are helps me map to, let's see here. And I just use a boring blue. 1 is here, 2 is here, 3 is here, 4, 5 is here, 6 is here, and 7 is here. And I'm going to leave the zeros blank, training wheels off. Okay. I can't make a group of 6 because I can't get 2 to the power of something to be 6, but I can make 2 groups of 4, which is going to require some overlap, but that's allowed. So this group here, my first group, is summarized by, okay, X is off, X is on, so that's not held steady. Moving on to Y. Y is off, Y is on, but for all of these, Z is on. So Z is on, summarizes that entire group. My next group, I would try to look for kind of being able to wrap around or something like that. But what I'm going to do is I'm going to make a group of 4 here because they have to be next to each other. And I want to make as big of a group as I can, right? So even though I've already used this group here, I want to overlap it because it makes for a simpler simplification. Right? Whereas if I only use this column, right, that would be summarized by Y on, Z off. Whereas here, if I use the entire square, I could summarize it as Y on, right? Looking here, X is off, X is on, fine. Y is on, so that's steady. Z is on, Z is off, nah. So Y is on, summarizes the entire group. So therefore, f of x, y, z is y plus z, or z plus y if you prefer. Good warm up. Okay, great warm up. So last day, I introduced something that I'm calling example A, which we have kind of worked from start to finish. And so now we're going to keep going on that example A, and we're going to reduce it or simplify it using Karnaugh maps. Oops. So in part 1, what we found was that f of x, y, z had a DNF of 1, 3, 6, 7. We want to find the minimal sum of products for f of x, y, z by using a Karnaugh map to simplify, which is what we've been doing. I don't really call it the minimal sum of products because I'm just going to say use a Karnaugh map to simplify it, but it is a minimal sum of products, I guess. Okay, we know what to do. Let's draw our map. X, Y, Z, 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Remembering the dance, right? I've got 1, 2, 3, 4, 5, 6, 7. Now there are options, but there's only one optimal option. Okay, what could you do? So remembering you're always trying to make as large of a group and trying to capture as many points as you can in one move. But so one of the wrong moves that you could make is you could lump these two together. Why is that a wrong move? Because then you're leaving this little guy on its own and this little guy on its own, and they would have to be lonely groups or groups of two, but then you'd have 3 groups of 2 instead of capturing all of them in just 2 groups of 2. That's better. Right? And so here, I'll start with this one. How do I summarize it? X is off for both of these, so that's steady. Y is off, Y is on. Nope, that's out. Y is on, or sorry, Z is on, Z is on. All right. X is off, Z is on. I have an error in my notes, which throws me off. I had X is off, Y is on, but that's not true. Feeling confident. Any objections? Great. How would I summarize this? Now X is on. Know that much. That's steady across this group. And Y is on, Z is on, Z is off, so it's out. Nice. I'll make a note here, right? We don't do this one because it would be redundant. Right, you've already captured them, so you don't need to make another group. F of X, Y, Z is X is off, Z is on, plus X is on, Y is on. Nice. Yeah.
For the one circle like with the red.
Yeah.
Let's say Y and Z.
So you could, but you don't want to do this one because you've already captured all of these points with just 2. And so if you're able to capture all the activity in as few moves as possible, then you're done, right? So you don't want to add on a third one. And just as a cautionary tale, I guess,
Oh,
let's have a look at, right, another option is if I didn't do this and I didn't have this and I didn't have this, and maybe initially, especially because I'm not very good at seeing these groupings, I might try to do something weird like that. Even I recognize it's weird. But then, right, if this is 1, then yeah, how would I summarize this thing? I would summarize it as X is changing, Y is on, Z is on. But I would still need to capture this one. And instead of just doing 1 on its own, I always want to make the biggest group that I can. And same thing with this one. I want to make the biggest group that I can, right? And so now this yields 3 groups instead of 2. So that's kind of a practice thing, is seeing those and saying, oh, but then I would have to rearrange and create more groups than I have to. About 4 variables. Dun, dun, dun. For 4 variables or literals, if you want. And maybe I'll put this on a fresh page because the table's a little bit bigger. Or our map. Our map becomes this. Get nice and big. Now I'm going to need 4 rows and 4 columns, because now we use W, X, Y, Z. Same thing. Remembering that the weird ordering still applies if we're moving down, right? So it still applies as it did before. And so what we have is we have 0, 0, 0, 1, 1, 1, 1, 0, right? Notice the order. Our columns stay the same as they have been: 0, 0, 0, 1, 1, 1, 1, 0. In terms of our labels, right, as long as we keep track of our dance moving across, but now also moving down, right? So it's gonna go like, it's gonna go a little something like this: 0, 1, nope, 2, 3, 4, 5, 6, 7, bump it out, bump it in. Then once I hit this weirdo, I have to go down 8, 9, 10 out to the bottom right, 11, then jump up a line, 12, 13, 14's out here, 15. Right, so notice here that we did the same dance, but twice. It's kind of like, what is it? You have to pat your head and rub your stomach. So one thing that I want you to make a note of is, like I was saying before, so the table, it cycles left to right, right? Or just kind of in a circle, but now it's also going to cycle this way, right? Because by the same logic, then I could have listed these. I could have started at 1, 0, and then gone 0, 0, 0, 1, 1, 1, 1. Doesn't matter. I'm asking you to use this order, but that doesn't mean it's the only order, right? So now we can, so note the table cycles from top to bottom, or some version of that, as well as left to right. So when you're looking for groups, right, your groups can go like this or like this. I've already promised they don't have 4 on the final exam, but it's worth practicing. But for me, I I always have to check it with a Karnaugh map simplifying app. Yes, it's true. And I posted the smallest assignment you'll ever see on this stuff. I'll post some practice problems, but I couldn't find any. And honestly, I'm too lazy to make any. So post some practice problems, but enjoy the tiniest assignment ever. We've got an example, don't we? Way up here. This one. Find the minimal sum of products representation of this function with 4 literals. And so now definitely, I'm not going to write the zeros because it's going to get very boggy if you do. Yeah, and so I'm going to start with my table here. Got X, oh, sorry, WX, YZ. 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. I have 1 in 0, 1, 2, 3, not 4, not 5, not 6, not 7, 8, which jumps way down to the bottom. Oops, I wrote 8 instead of a 1 there. 9, 10 is way up here in the corner, and that's it. The goal is as large of a group as you can possibly make in as few moves as possible, right? They're allowed to overlap, but not too much. First one's nice, or the first one that I see, right, is, well, this group of 4. What you would want to do is you would want to check to see if you could link it with another group of 4 down here, right? Because then you could make a group of 8, but we can't, right? So we're off the hook. How do I summarize this group, the green group? W is off, X is off for all of these. Y is changing, Z is changing. And so I'm going to summarize it as W is off, X is off. I got a good chunk of them. You guessed it. Grabbing these corners, right? 1, 2, 3, 4. I can make a group of 4 if I roll it and scrunch it. So here, I can make a group of 4. It's probably the trickiest one. Especially when we're trying to see what's held constant here. So if you wanted to, you could write the 0, 0 line down here again if it helps, right? And you could do what? You could write the 0, 0 line or the column over here and group them as a group of 4 temporarily, right? To see, or stretch our minds here. I am seeing that W is off and W is on. Okay. How about X? X is off X is off for all of these. So X is off is a summary of it. But there's more, but wait, there's more. Looking at my Y's, Y is off, Y is on. So doesn't matter what Y is doing. Z is off and Z is off. So that as long as X is off and Z is off, then you've summarized this group. And then we're so bummed because we've got just one little lonesome one over here. And instead of wrapping it up in just one or even two, what could we do? Roll it back up here into a group of 4. Wow.
I was gonna say, could you just, like, for the first one, we have like the first row, then like the number 2 where like the 2 ones are together. Could you just circle them and leave like the last one, the bottom right corner by itself? Can you do that or no?
This one?
Yeah.
Yes, but you'd want to capture it in as big of a group as possible.
Oh,
So you want to link it up. And the biggest way that you can do that is by grabbing all the corners. But these are kind of your go-to moves, right? Checking the corners, checking if you can loop it back up. So then how do I summarize this thing? In the top one, W is off, and then in the bottom one, W is on, so it's out. In the top one, X is off. In the bottom one, X is off, so that's good. Let's write that one down. Y is off, Y is off, Y is off, Y is off, good. So Y is off. Z is off and then Z is on, so doesn't matter. As long as X is off and Y is off, we can summarize that whole group. So therefore, F of W, X, Y, Z is W off, X off, plus X off, Z off, plus X off, Y off.
would it be a G instead of that?
Oh, I do have a G coming up, don't I? The next one. Got me sweating. I know I have a G and I know I'm gonna forget. So when you said that, I thought, oh boy. Now I've done it. Our final example is G of W, X, Y, Z, which we found the DNF for last day. It's quite large. Put it on a fresh page. Now I've got this G, W, X, Y, Z. Has a bunch of min terms, and I'm just going to make a note that I have 4 literals. So I'm first going to set up my table, and then I'm going to map these into my map, I guess. And then we're going to simplify. W, X, Y, Z, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. As long as you remember the dance, then you're okay, right? 0, 1, 2, 3. I'll use my pointer. 0, 1, 2, 3, 4, 5, 6 I have, 7 I have, 8 starts down here. I don't have an 8, I don't have a 9, I have a 10. I don't have an 11, but I do have a 12, 13, 14, 15. Nice. Give it a go on your own. Let you fly on your own. W was that? Or is that off? But maybe I missed something. We'll see. Time will tell. I've got a gimme group. That's nice. So let's do those first. I can summarize this as W on, X is on, and then it's varying across all the Y's and Z's. I can see that, or you can confirm it as you move through. So W, X is my first grouping, which caught a lot of action. Then my next group that I see, remembering to go for as large of a group as you can, I'm gonna go for these 4. Now, how do I summarize this? W is off, W is on, it's out. X is on, X is on, that's nice. Y is on, Y is on. Z is on, Z is off. Nice. Now, the sneaky one here is this grouping. Because you want to write it in as few terms as you can, which means a bigger group, right? So instead of just writing it on its own, you're going to lump it into as big of a group as you can still.
We're doing a group of 3.
No, because it has to be 2 to the power of something
Oh, right.
for our groups. And to summarize this, W is on, W is on. X is on, X is off, that's out. Y is on, Z is off. W, Y, Z. Therefore, G of W, X, Y, Z is WX plus XY plus WY, Z. Hey, nothing's off in here? Weird. Oh, thank you. You knew it was too good to be true.
I was gonna say, for the graph, isn't the fourth line where it's like 1 and 0, that's like 12, 13, 15, 14? Like, I don't know if the graph's like just different.
This one?
Like, I don't know, like for me, when I drew like my ones, like all four of them was like on the 1 and 0.
So you want to make sure that you shake up your order on this one too, if that's what's
Oh.
going on. Because you want to go 0, 1, 2, 3, 4, 4, 5, 6, 7, and then 8's down here.
Oh, they're not on the, oh, they're on the
8, 9, 10, 11, 12, 13, 14, 15. Yeah, it's a double whammy. And it sounds like maybe that's what happened. Right. And there you have it. The course is done. You did great. In fact, I've got a sticker for you. This week quiz. No, great job. Friday, final exam review, if you want it. Otherwise, see you for the final exam. Eek.
I'll take the second message that.
Stop this.